Hi, my name is Ariana, and this is my video lab report for Physics 2012 with Dr. Barron's Lab 1 charged tapes. The purpose of this experiment was to prepare charged pieces of Scotch or clear tape, and after observing their interactions, experiment to determine approximately how much excess charge was on one piece of charged clear tape. The results of the experiment are that the tapes were discovered to be positively charged and therefore repelled each other, and the charge of each tape was 1.07 10 to the negative 8 coulombs, and the tapes were found to be electron deficient, with the ratio of electrons to atoms being 1.67 10 to the negative 7 electrons for each atom. Some important background concepts are Coulomb's law, which explains why like charges repel and opposite charges attract, and the formula is shown in the slide. The force of gravity is another important concept, which is given by the equation shown, and Newton's second law is a final important concept, where the two forces acting in this experiment are electric and gravitational and sum to net force. Models for this lab are an experimental model and a computational model, where the system is the tape floating, the surrounding is the bottom tape in the earth. Some assumptions are that each U-tape has the same net charge, and each U-tape is treated like a point charge, where the charges are concentrated in the center of the tape. Also, air resistance is negligible. The reasoning for these assumptions is to simplify calculations, as we only need an approximation for this lab. The experiment procedures are shown to the left. First, two charged tapes were made by ripping apart a base tape and an upper tape twice. The upper tapes became the charged tapes. Second, the interactions with the upper tapes and the other objects were observed. I observed the upper tapes to be positive because they are attracted to a negatively charged pen. Third, one upper tape was floated above another upper tape, and that distance d was recorded and used in further calculations. The initial conditions are shown in the table, which were also used in calculations. Here are the calculations in the experiment. Force of gravity on a U-tape was calculated by multiplying the mass and the Earth's gravitational constant, as this experiment took place close to the surface of the Earth. The force of gravity is in the negative y direction, and the force of electricity was calculated using Newton's second law in a free body diagram. The charge of the tape was calculated from Coulomb's law, and the number of deficient electrons was calculated using the ratios. Here is my code for the computational model. The GlowScript code is also linked in this slide. I started out defining the constants and then calculated the gravitational and electric forces using the formulas I discussed in the background. I created objects and vectors using the previous calculations to determine the vectors' magnitudes. The images of these objects and vectors are shown in the results. The results of the computational model are shown to the right and match my calculations for the experimental model. Some sources of error through this lab could be loss of charge when handling tape, estimating weight and other measurement/rounding error, and error from assumptions such as treating tape as a point charge, assuming each tape has the same charge, and ignoring air resistance. What if the electrons had positive charge and the protons had negative charge? What would change about the observations you made with your tapes and the other charged objects? Well, first, many of the observations would not change except losing protons rather than electrons. Tapes would still have like charges and therefore repel, but the negatively charged pens, assuming that it is still negatively charged, would also be repelled. Furthermore, neutral objects polarized with the tape would now be attracted. The next question was, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with your hands or other objects? Charged tapes coming in contact with your hands and other objects leads to the transfer of electrons. Since the tapes are electron deficit, electrons can transfer onto the tape from other objects, which would decrease the net positive charge on the tape, and the measured distance between the tapes would be lower than the theoretical value in the experiment. Thank you for listening to this lab report.